what? That the IBDP part of the chromatography, we have to see that the chromatography is a process by which we separate out mixture of substances, right? Usually in a solution, we have got a solute and a solvent, right? Only one solute, right? We have, right? And one solvent, right? And we separate out. Suppose we want to separate out the solute from the solution, it is called as crystallization. You want to separate out the solvent from the solution, it is called as simple distillation, right? Now, in the chromatography, you have got a special case where you're having more than one solute, right? And it's solute 1, solute 2, solute 3, right? It can be more. To in a solution. So chromatography takes care of this portion that we have to separate out different mixture of the solutes in a solvent, right? And in this process, what we do, we take care that each solute will be having different solubilities in a solvent. Is it clear? You get my point? We take care of this part that it will be having different solubilities in a solvent. Is it clear? Do you get my point? In a solvent. That's a very important point to master, right? We'll be having different solubilities in a solvent, right? So we all do what? We are doing a simple experiment. This is a simple chromatography. You take ink, and we know that ink is made up of what? Ink is made up of red, blue, and yellow, right? These three solutes are there, right? In a solvent, right? Now, we want to separate out this red, blue, and yellow. In this trial run, what we do, we place a ink and we dry it on a filter paper, and after that we're adding a solvent. Here we have taken a water as a solvent. When we add water as a solvent, what happens? This solvent will be spreading like this, right? When it is spreading out, right, what happens? We see that the individual solutes are separating out, right? Isn't it? We see that the yellow dye had traveled the farthest and the blue dye traveled the least. So we can understand that this chromatography technique will be having that principle. Which principle you are using over here? We're taking the principle that the dyes or the solutes have different solubilities in water, right? We added water over here as a solvent. We could have taken ethanol also, right? They're having different solubilities. The yellow dye was the most soluble and the blue dye was the least soluble. So we take the principle of what, that they are having different solubilities in the solvent, right? Is it clear? So they'll be
Yeah.
traveling at different rates. This principle is used to separate out the solutes from the solvent, right? Is it clear? Fine. Now,
Yeah.
in this paper chromatography, if we delve deeper, right? Delve deeper, we can understand that we first have to what? We first have to there's a basic way by which we do. We take suppose we are taking a mixture of solutes, unknown solutes, which we predict that okay, it can have A, it can have B, it can have C, it can have D, and that after that we take a chromatography paper and we draw a pencil line. We use a pencil line because we cannot use a pen. The pen will be smudging out, so we use a pencil line to draw a line. After that, we put a unknown solute over here, solutes which are there, and we put over here, right? Then we roll it down and put it into a glass tank. Now here we take a solvent over here. Remember, the solvent, choice of the solvent is very important, right? As we discussed over here, we have taken water over here, right? It may be the fact that if we had taken propanol over here, it might be that the blue dye would have traveled faster, right? More soluble. It might be. So the solubility will be depending on what? What is the solvent you have taken. It might be that the yellow dye was more soluble in water solvent. Might be that it would have been least soluble in that propanol, right? So this is the case. We have to understand that we separate out, and after that we roll it down and we place the solvent just below the pencil line. This is called as the baseline also, right? Right, fine.
Yeah.
Baseline, this. And what happens? The solvent goes up, right? And what happens? We stop this when the solvent is here. We take this out. we dry it, and we see that the individual solutes are getting separated, right? Now, here is a very important point to understand that the detailed part of it is that chromatography will be involving a technique where there are two phases which are there. What are the two phases which are there? One is called as the mobile phase and stationary phase. Stationary phase is the paper we are using, stationary phase. And the mobile phase is what? Mobile phase is the solvent we are using, right? So the solute will be having attraction for the stationary phase as well as the mobile phase, right? This is clear. The
Yes.
solute will be having attraction to the stationary phase as well as the mobile phase. Now, if the solute has got more attraction with the stationary phase, it will be traveling slowly. Whereas if the solute has got more attraction with the mobile phase than the stationary phase, it will be traveling faster. Mobile phase, if it is more attraction than, see, than, I'm using this word, than the stationary phase, it will be traveling faster. So this differential attraction between the stationary phase and the mobile phase will be helping the solutes travel at differential speeds, right? And thus we will be separating out, right? Now, moving to this part, we learned about RF value. The RF value will be just very important part. RF value is a constant of a particular solute in a particular solvent, right? Is it clear? As I have told you that if you have taken propanol instead of water, it might have been that the yellow dye would have been traveled slower, right? Isn't it here, right? Is it clear? The solvent is very important. If you change the solvent, the RF value changes. If you change the chromatography paper, the RF value will be changing, right? So RF value is a constant of a particular solute in a particular solvent and a particular chromatography paper, right? That's very important, right? Because the attraction might be different, right? Is it clear? So this is the way by which we find the RF value, the distance moved by the substance X divided by the distance moved by the solvent Y, right? So this is the RF value we are getting. Now, moving to this part, we have to also understand that the RF value will change when we change the solvent or when we change the chromatography paper or the stationary phase, right? This principle is called as the chromatography in your IBDP, right? Thank you.